Hello and welcome to IP Study video lectures. And today we are going to discuss chapter 14 from grade 7 social science, and the name of the chapter is water. In this chapter we are going to discuss topics like water cycle, distribution of water, salinity of ocean water and circulation of ocean water. So we all know our planet Earth, it is also called blue planet, because Earth appears blue when looked from space, outer space. This is because of presence of huge water bodies on the Earth's surface. In fact, water covers 71% of the total Earth's surface area. However, the distribution of water, it is not even, or water is not evenly distributed on the Earth's surface. Okay, so water on the Earth, it is present in the form of lakes, rivers, seas, oceans, even trapped in glaciers. And all of these different forms of water collectively forms the hydrosphere. So we know water is very vital for the survival of life or even existence of life on Earth, and water is in constant motion, or it changes its form. Okay, there is a cyclic process in which waters move from different sphere, from hydrosphere to lithosphere or atmosphere. So there is a cyclic movement, and this is called water cycle or hydrological cycle. So our first topic is water cycle. So we already discussed water is in continuous or constant journey from one sphere to another. Okay, if you look at the diagram over here, so this water cycle, it begins with evaporation of water from different water bodies. So once the water evaporates, it turns into water vapor. Okay, because of the heat of the sun, the water turns into water vapor. Once it turns into water vapor, it rises up this portion. Okay, so once it reaches the atmosphere or to a certain height, the process of condensation begins. So as a result, water vapor, it turns into water droplets. Okay, so in time these water droplets become very heavy, and then it comes into the Earth's surface as precipitation. So precipitation can happen in different forms. It can happen in form of rain, snow, sleet, hailstones and other forms. Okay, and again once the precipitation happens, the water that it falls on the Earth's surface, and then again it joins the ocean or the big water bodies through rivers and streams. Thus there is a cyclic movement of water. So it is called the water cycle. Let us now see the second topic, that is the distribution of water. We have already discussed that water is unevenly distributed. Okay, approximately 97.3% of the water on the Earth's surface, it is saline, and it is found in oceans or seas, and the remaining 2.7% is the fresh water. However, we have to understand that in this 2.7%, 69% is trapped in glacier and ice sheets. That means we cannot use it. Remaining 30%, it is in the form of underground water or groundwater. Thus, only less or 1% or even less than 1% is found in rivers, streams, lakes, ponds. So thus we can see that only 1% of the total fresh water is available for human, for drinking or for other various purposes. So that is the reason why we face scarcity of water. Even water covers 71%, we have scarcity of water. It is because of this particular distribution of water. So now let us see major oceans in the world. So what are oceans? So oceans are the vast bodies of saline water that covers almost 3/4 of the Earth's surface. And how many major oceans are there? 5, right? Firstly, Pacific, Atlantic, Indian, Southern Ocean, and lastly Arctic Ocean. Okay, so when we talk about the Pacific Ocean, if you look at here, this is the Pacific Ocean. Okay, this portion is the Pacific Ocean. So Pacific Ocean, it is the largest and the most deepest ocean. Okay, it stretches from the western coast of Northern and Southern America, this portion. Western coast of Northern and Southern America, and then it stretches up to the eastern portion of Asia and Australia. Okay. After Pacific Ocean comes the Atlantic Ocean, this portion. Okay, it divides the North America, South America with Europe and Africa. Then comes Indian Ocean. Here, it is bordered by Asia, Africa, and Australia. Then comes Southern Ocean. Here, it surrounds the Antarctic continent, and lastly comes the Arctic Ocean in the northern part. It surrounds the Arctic. Okay, or the North Pole. Arctic Ocean surrounds the Arctic region or the North Pole. So now let us discuss salinity of ocean water. So what is salinity? So salinity, it refers to the amount of dissolved salt or minerals in the ocean water, or the dissolved salt present in the ocean water. Okay, so ocean water, it is saline in nature or salty in nature because it contains large amount of dissolved minerals such as sodium chloride, potassium, magnesium, and other minerals also. Okay, so when we talk about the average salinity of the ocean, it is 3.5% or 35 grams per 1000 grams or 35 grams per kg. Okay. Also, we have to know that this salinity, it is very high in the region where the evaporation rate is very high. And the logic behind is when water is evaporated, the water turns into water vapor, but the minerals, it does not turn into water vapor. So that means it leaves the salt behind. Thus, high salinity in the region where evaporation is high, or even in landlocked water bodies. If there are no fresh water coming and mixing into a particular water body, the salinity in that water body, it increases. For example, Dead Sea or Lake Van. These two are one of the highest saline water bodies in the world. Okay, so now there might come a question, from where does a particular ocean gets its salt or minerals? So most of the minerals, it comes from the land where we live. Okay, when there is a rainfall, the water, it flows as a river or stream, and once a water flows over a region, the minerals present in that region, it get dissolved into that stream or river, and that river, it carries that dissolved mineral with it, and then it deposits it in the ocean. So once the river reaches the ocean, it not only mixes with the ocean, but it also deposits the salt or minerals that it is carrying, thus increasing the salinity of the ocean. Okay. However, there are certain factors on which salinity depends. For example, rainfall, melting of ice, or even snowfall, or there are waves. We should understand that when fresh water mix with the ocean, the salinity decreases, and when there is when iceberg or even big glacier melts, it adds fresh water, thus decreasing the salinity. So there is a variation in salinity in different part of the world, okay, or in different water bodies. So thus we can conclude that some water bodies are very salty while some are less salty because of all these factors. So now let us come to another topic, that is circulation of ocean water. So the water in the ocean, it is not static, okay, it is constantly in motion. So the circulation of ocean water refers to the movement of water within the ocean. Okay, so the movement of water within the ocean is called the circulation of ocean water, and it normally moves in 3 different forms. Firstly, waves, tides and ocean currents. So 3 forms of ocean water circulation: waves, tides and ocean currents. Okay, so now let us see what are the factor or the force that causes the movement in ocean water. Firstly, wind. Okay, so it is the wind that causes the water to constantly move because of the friction it causes. Okay, when the wind blows, there is a friction with the wind and the water in the ocean surface. So there is a flow or there is a break in the what we can say state of the water, so it moves. Okay, secondly, salinity of ocean water. Okay, so when there is a variation in salinity of ocean water, the water also moves. Okay, variation in density of ocean water. So when there is a variation or difference in the density of a particular ocean water bodies, then the water also moves. So now let us discuss the first form of ocean circulation, that is waves. So what are waves? So waves are the rhythmic movement of ocean water or the water on the surface of the ocean. Okay, so it is caused by the movement of wind across the surface of the ocean water. Okay, so when wind blows, it creates friction which results into the formation of ripples, and these ripples in course of time turns into waves. Okay, so there is a direct connection between waves and the wind. As such, the size of the waves, it is directly related to the force of the wind. As such, stronger the wind blows, the larger the waves will be generated. Okay, so now let us see the different parts of a wave. So the highest point on the wave, see, right? So this highest point, it is called crest, and the lowest point, it is called trough. Okay, highest point crest, lowest point trough. So another part is wavelength. So the difference between one crest to another, see, this is called the wavelength. The length between or the distance between one crest to another is wavelength. On the other hand, there is wave height. So what is wave height? Wave height is the distance between the lowest point and the highest point of a wave, such as the distance between crest and trough is a wave height. Okay, I hope you understood the different parts of the wave: crest, trough, wavelength and wave height. So now let us discuss tsunami. So tsunami, it is a natural calamity. Okay, so how does tsunami origin, or what causes the tsunami? So tsunami, as we can see here in the picture, it is caused by the vibration that results from an underwater earthquake, landslide or volcanic eruption. So when there is volcanic eruption in the deep inside the ocean or the ocean floor, it creates a vibration, and this vibration, it displaces large amount of water and results into formation of gigantic walls of water or gigantic waves. And these waves, they travel at a very high speed, they are very destructive, and it damages property, even lives on the coastal region. So tsunami, it is a natural calamity or a disaster which arises due to the vibration resulting from underwater volcanic eruption, earthquake or even landslide. So now let us come to the second form of ocean circulation, that's ocean water circulation, that are tides. Okay, so what are tides? So tides are the periodic rise and fall of the ocean water due to the gravitational pull of the sun and the moon. It is the periodic rise. It is a periodic rise and fall of the ocean water caused due to the gravitational pull of the sun and the moon. Okay, so it occurs at a regular interval and twice a day, 2 times, okay, twice a day and at a regular interval. Okay, so when the tides rises, or when the sea water rises, it is called high tide, and when the sea water or the sea level goes down, it is called low tide. Okay, so now, tides, as I already discussed, are caused by the gravitational force or pull of the sun and the moon. One thing we have to understand, the gravitational pull of the moon is higher than the gravitational pull of the sun. Although the moon is smaller in size, it has higher gravitational pull than the sun, because the distance between the earth and the moon is less compared to the distance between sun and the earth. That is why the gravitational pull or the force of the moon on the water or the ocean water on the earth is higher. Okay. So now let us discuss spring tides and neap tides. So firstly, spring tides. So what are spring tides? So during the spring tides, the tides are the highest, and it occurs during the new moon or the full moon. So what happens during the new moon or the full moon? If you can look here in the diagram, the sun, the moon and the earth, in both new moon and full moon, they are in a straight line. As a result, the gravitational pull of the sun and the moon is highest here, because the moon is also exerting its gravitational pull. At the same time, the sun is also exerting its gravitational pull, thus leading to the rise in the sea level, causing this swelling of the ocean water or sea level, leading to the highest tides or spring tide. Okay. On the other hand, we have neap tide. So it occurs when the moon is at the first quarter or the third quarter, and in this position, the moon, the sun and the earth makes a right angle. So as a result, what happens here, if you can see here, moon is exerting its pressure here, exerting its gravitational pull here. On the other hand, sun is exerting its gravitational pull here. So what happens is, both of these, moon and the sun, they compensate each other gravitational pull. As a result, the tides that arise, they are of moderate size. Such tides are called neap tide. Okay. See, moderate height, the moon, the sun, gravitational pull. So both of them are balancing each other's gravitational pull. So now let us see the uses of tides. So in what way are tides useful to humans? Firstly, tides are useful for fishing and navigation. So because during high tides, as we all know, fish also moves with the movement or rise of ocean water. So during high tide, the ocean water or ocean level increases, and it reaches near the coastal areas. So fish also moves near the coastal region. Thus, it is easier for fishermen to catch fish. Another is navigation. So during high tide, many of this ship, it is easier for them to get inside the dock, or at the same time depart from the dock with the help of the rise in the sea level. So it helps in navigation. Thus, it contributes to shipping and trade. So second point is during the high tide, saline water of the sea, it spreads into the low-lying region of the coastal areas. So what happens is, this saline water, it is collected and it is spread out to form salt. So once this saline water it evaporates, it leaves behind salt, thus contributing to the manufacturing or formation of common salt. Third is, this tide, it is also used to generate electricity, okay, renewable energy. And this has been done in countries like Canada, UK, France and Japan. Third, I've already discussed this. It plays an important role in the coastal ecosystem because marine organisms, they move along with the falling and rising water of the sea. Okay. And lastly, I've already discussed this in the first point. When there is high tide, the water level near the coast rises. Thus, it allows big ships to enter or leave the port. Thus, it helps in navigation or shipping. For example, Kandla port in Gujarat and Diamond Harbour in West Bengal are tidal ports. So, they take the help of tides for shipping, docking ships. So now let us discuss the third form of ocean water circulation, that is ocean currents. So what are ocean currents? So ocean currents are the continuous directed movement of the ocean water from one place to another. Okay, they are like rivers flowing within the ocean. Okay, and they move in clockwise direction in the northern hemisphere. Why? They move in anti-clockwise direction in the southern hemisphere. And why is this so? This is because of the Coriolis effect. We know that because of the Coriolis effect, the water and the wind, it is deflected to the right in the northern hemisphere, while it is deflected to the left in the southern hemisphere. So what are the different factors that causes ocean currents, rise of the ocean currents? Firstly, varying temperature or difference in temperature or density of ocean water, difference in density of ocean water. Secondly, shape of adjoining coast. Thirdly, the direction of prevailing winds. And lastly, the rotation of the earth. So these are all the factors that causes ocean currents. So now let us discuss the types of ocean currents. Firstly, warm currents. So what are warm currents? So ocean currents that arise from the low latitudes of high temperature near the equator or tropics and flows towards the high latitude of low temperature towards the pole are called warm currents. For example, Gulf Stream. So these warm ocean currents, it increases the temperature of the region it flows into. Okay. On the other hand, cold current. These are current that flows or that origin from the higher latitudes of low temperature, that is polar region, and flows into low latitudes of high temperature, that is tropics. So like warm currents, it decreases the temperature of the region it flows into. Okay, so warm currents, it increases the temperature in the areas it flows into. On the other hand, ocean currents, it decreases the temperature. So thus, ocean currents act as an equalizer of the global ocean temperature. So now, importance or significance of ocean currents. Firstly, they have great influence on the climate of coastal areas. Already discussed, when warm ocean currents arrives, it increases the temperature, or on the other hand, when cold currents, ocean currents arrive, it lowers the temperature of the coastal region. Second, it plays an important role in the distribution of temperature all over the globe, right? We have already discussed it acts as an equalizer of the global ocean temperature. Thirdly, it helps in navigation. Thus, the ships that are sailing on the direction of the ocean current sails faster with the help of ocean currents. Thirdly, the best fishing grounds are developed when warm ocean currents and cold ocean currents meet. Lastly, warm currents reduces the danger for sailing ships because it melts the drifting iceberg. Okay, so these are the significance of ocean currents. Now let us summarize the key points that we have discussed in the lecture. Firstly, water, it covers 71% of the area of the Earth's surface. Pacific is the largest and the deepest ocean, right? So average salinity of the ocean is 35 grams per 1000 grams or 3.5 Ocean moves in three different forms: waves, tides and ocean currents. What are waves? It is the rhythmic movement of the water on the surface of the ocean. Okay. Tides, on the other hand, it is a periodic rise and fall in the sea level caused due to the gravitational pull of the sun and the moon. And lastly, ocean currents, it is a permanent, continuous and directed movement of the water, ocean water from one place to another. So with this, I conclude the chapter. I hope this lecture was able to clarify your doubts regarding this chapter, and we will again meet in our next video lecture. Thank you.